Unit 3 Introduction to the Abap Dictionary. Lesson: Data Modeling and Descriptive Elements in the Abap Dictionary. Lesson Overview. In this lesson, you will get an overview of data modeling, which has to be done before the application development. Furthermore, you will learn about the basic descriptive elements in the Abap Dictionary. You will also find out when and why it is appropriate to use data types, data descriptions, from the Abap Dictionary. Business example. When you define data objects in your Abap program, you should use the advantages of the Abap Dictionary. Data modeling. In the development of business application software, parts of the real world must be represented in data form. We refer to an entity relationship model. You use this data model as the basis for implementing appropriate table definitions, transparent tables, including their relationships with each other in the Abap Dictionary. Inside our SAP system, we have a relational data model of a flight example. This example comes with all SAP systems. It is a flight data model example. So, we define several tables to model an airline and all of its operations. So, for example, we define a transparent table for the airlines. That transparent table is connected or related to the flight schedule table. The flight schedule table at the same time is related to the flights table, that is related to the flight bookings table. Another example, as we can see, is the airport tables and the city tables are related through the city airport assignment. And so on. The flight customer table is related to the flight booking table. The sales office and the travel agency are both related to the flight booking. Before we start creating our tables or transparent tables in the Abap Dictionary, we need to first model our tables. Let's take a look inside the SAP system how these tables are related. So, inside our SAP system, let's navigate to the Abap Dictionary. That will be transaction SE11. So we type SE11 in the command line. We press enter, and we are inside the Abap Dictionary. This is the initial screen. So let's take a look at the SCAR or SCARR transparent table. This is the table for the airline. So we type in SCAR and we click on display. We can see our table, the SCAR table. We have a short description, this is for the airline, and we can see all the fields inside this table. The key fields in this case are the car ID and just the car ID, sorry, this is the only key table, the only key field, sorry, and demand T, this is the other key field. If we want to look at the relational model for this table, or if we want to know what other tables are related to our airline table, we can use the display object list button. So we click on it and the system presents to us the data model for the SCAR table. So let's look at what other tables are related to this one. So we navigate to the dictionary object, database tables, and we can see all of the other tables related to our SCAR table. In this case, these are the tables that are inside the package SAP BC underscore data model. If we want to see in a graphical way the relationship between tables, we can use this icon here. Let's take a look, for example, at the flights table. We double click on as flight. The system displays us the transparent table as flight. We have the short description, and we can examine, for example, the key fields, our car ID, con ID, and FL date. These are part of the key for this table, the primary key. Let's take a look at the graphic relations. So these are the foreign key relationships. So as we can see, we have our flights table related to the schedules, related to the airline, related to the clients. We close here and we go back, and we can continue examining all of our next tables. Working with the object navigator. Let's continue with the flight data model. This flight data model contains entities for all business information that is logically connected, such as cities, airports, airlines, flight routes, and flights, and so on. These entities all relate to each other in certain ways. Each flight schedule contains exactly one airline, one departure airport, and one destination airport. Each bookable flight always belongs to exactly one existing flight schedule. Assignments can be set between cities and nearby airports. For example, in the system, we have these 4 transparent tables. As we watched earlier, we had the SCAR table. That was the transparent table for the airlines. That table had 2 primary keys: the field man DT and the car ID. As you can see, the other tables that are on the system related to the flight data model have the same car ID as the primary key. This way they relate to each other. For each entity fit in the data model, the developer creates a transparent table in the Abap dictionary. This is merely a platform-independent description of a database table, not the database table itself. A transparent table contains different fields or columns to allow you to store and manage data records in a structured way. You have to declare table fields as key fields when their content is to be used for the clear identification of data records. The key value of a data record is a unique ID within the table. Descriptive elements in the Abap dictionary. Before we deal with a transparent table, we must first explain 2 other dictionary terms: the data element and the domain. A data element is a total description of a field. This includes the semantic as well as the technical field attributes. The technical field attributes such as data type and field length are usually not specified in the actual data element, but by means of a reference to a domain. Data elements can be used for defining program interval variables or for describing fields of transparent tables. For example, inside the system we have a data element and a domain for the flight model we were talking about earlier. So we have a data element called S_car_ID. you can find this data element inside the SAP system. We're going to take a look at it in a while. This data element has some attributes. It has a short description, a documentation, file ID, the data type, a search help, and so on. Inside the data type, you can make a reference to a domain. We can also find the domain inside our SAP system. This domain defines the type of this data element. In this case, it is a card 3 type. And it also has a value range in case it needs a value range. Let's take a look in our SAP system for the data element s_card_id. So first, we navigate to the Abap dictionary, transaction SE11. Inside our Abap dictionary, we need to look for the data element sCarID. So we select data type and we type the name of our data element and we click on display. The system then displays us our data element and our short description. This is a data element for the airline code. We can see some attributes, some data type. We can see the domain for this data element is s_car_id. It has the same name. It doesn't matter because this one is a domain and this one is a data element. So we can see the domain specifies the data type. It is a car data type of length 3. We can see more options for this data element. We can see the search help attached to it, a field label for it. It will be the airline label. This label will be displayed in all SAP screens that use this data element. Let's take a look at the domain. So we double click on the domain and the system takes us to the attributes of this domain. It's a data type of car of 3 characters. And as you can see, we have other options. We have a value range if we want to restrict our domains to certain fixed values. In this case, we don't have a value range. This is optional. And if we want just lowercase letters for this domain, we can use this option. And we can go back to our data element. So that's the way we can display a data element and a domain inside our system. In the Abap dictionary, a transparent table is an implemented description of the corresponding database table that contains the actual application data. The technical structure of a transparent table. A transparent table mainly consists of fields. You create fields for your transparent table. Each field is described by a data element that points to a domain. For example, the transparent table in the Abap dictionary. This is the transparent table SPFLI. This is the transparent table for the flight schedules. Let's take a closer look at it inside the SAP system. So we navigate to the Abap dictionary. Inside our Abap dictionary, we select database table and we type SPFLI and we click on display. We can see the short description for our table. This is a flight schedule. We can see all the fields for this table. We can see which are the primary fields or the key fields. It's car ID and con ID. And we can see, for example, the field car ID has a data element named sCarID. We can navigate to that data element by double clicking. Inside the data element, we can see the previous information that we already saw. Its domain, and we can double click and navigate to the domain information. SAP lets us navigate through their screens by double clicking on almost any element or text you see on the screen. So let's go back, and let's go back to our table. As we can see, each field has a data element. We always need to create the data elements first with their corresponding domains, and then we create the fields for our tables. The fields of a transparent table form the identically named columns of the corresponding database tables. Let's talk about structures. Usually, a structure in the Abap dictionary is used to centrally describe structured variables that are to contain the fields of various tables. You can then use these dictionary structures in the Abap program to define data objects, concrete structured variables, that either serve as temporary data storage in the program or as an interface for the field transport between the screen and Abap program. With structures, however, we refer to component and component type, as opposed to field and data element. It is possible to have a structure as the component of another structure. Let's take a look at a structure in the Abap dictionary. Let's look at the structure SPFLI_T. This is a combination of the SCAR and the SPFLI transparent tables. So once again, we navigate to the Abap dictionary, and this time we select data type to look at the structures. We type the name of our structure, SPFLI_T, and we click on display. The system then displays our structure. As I told you before, this is a structure combining the SCAR fields and the SPFLI fields of both tables. So you can see we have components and component types, different from tables that were called fields and data elements. We can see the attributes. We can see if these structures have an entry or a help check, and if they have currency or quantity fields. For example, distance is a quantity field. You have to make a reference to the distance ID field. This is because this is a field that it can be measured in units. So you need to tell the system what type of units you are going to be using to measure the distance. Such structures with included substructures as components are called complex structures. In contrast, structures with simple components are called flat. Data element. Using dictionary elements to define data objects within the program. For example, we have some Abap code here. We have some declaration of some variables. We have the myCaret variable type s_car_id. This was a data element. You can define variables using data elements. You can also define your variables in your Abap code using fields of a structure or a structure field. For example, this SBC400 FOCC is a structure. Dash con ID, this is the field. parameters PA underscore car type SP flee dash car ID. This is a table field. You can make reference to table fields to declare variables in your code. Data WA underscore FOCC type a structure. You can also declare variable structure types, and you can also declare structures type a transparent table. This structure would contain the same fields that the transparent table contains. The definitions of the previous graphic have the following meaning. The first one, the variable declare myCaret type S underscore car underscore ID returns a data object or variable of the type specified in the data element sCarID. The variable myConID type SBC400 FOCC-ConID returns a data object or a variable that has the same type as the structure field SBC400 FOCC-ConID. Parameters PA underscore car type SPFLE car ID. That returns an input field on the selection screen, as well as a variable that has the same type as the table field SPFLE-car ID. The structure, the variable WA underscore FOCC is a structure variable. It returns a structure variable that has the same type as the dictionary structure mentioned below. And finally, the variable WA underscore SPFLE type SPFLE returns a structure variable which has the same type as a line of the table SPFLE. Okay, so let's create a program and let's declare some variables using structures, data elements, and fields of transparent tables. So let's go to the Object Navigator. Let's navigate to our package, C Abap course, and let's create another program. We're gonna call this program C data underscore types. We are going to uncheck this and we click OK. The name of our program, it's OK like that. It's gonna be an executable program, and we save our program. Now, we're going to declare some variables using data elements. So we use the Abap keyword data LV underscore 1. I like using LV because this means local variables. Since we are working with local variables, I like using this structure. But you can use the structure that you want. Type, and let's use data element S underscore car underscore ID. So type S underscore car underscore ID. This variable will be the same type as this data element. To make sure this data element exists and to look at its type, we can double click on it. So we double click. Abap, before exiting this window, Abap asks us if we want to save. So yes, we save. And then the Abap system shows us the data element sCarID. We can look at its domain, and it is data type car 3. So our variable will be this same type. It will be a character variable with length 3. So this is the declaration using data elements. Another way to declare variables is using the table fields. So we use data lv2 type. We're gonna use the table spfli, this table. So spfli dash, this indicates we're going to use a field of that table. We are going to use the field car name. If we are not sure about if this is the correct field name, we double click. We're presented with the same warning. Yes, we save, and the system gives us a warning. The car name does not exist in the newest version. Click OK, and we see that we don't have this field, so we're going to use another field from our same table. Let's use the city from field. So I highlight it, I copy it, and I go back to my program by clicking on back. So now I'm going to use the other one. So dash, and I paste my city from. This is a declaration using table field. A third way is to declare a variable type structure. So we declare a local structure, that's why I use ls underscore. I want my structure to be called spli type, and I'm going to use this structure. So I copy it and I paste it. And this is a declaration using structure type variables. We double click to make sure our structure is correct. Yes. So you can see this is a structure and we have all these fields. So now let's write some content to our screen using these variables. So for example, for the first variable, we remember it was a car3 type, so we can do this. Assign 3 characters to our variable. To the second variable, it is a city from. So I don't remember exactly what was the type of this, so I double click to go see, and then I see this, a car, and it accepts 20 characters. So I can write something like this then. City from, I'm gonna use my hometown city, Tegucigalpa. And for the third variable, that is the local structure, we can access its components using a dash. So I don't remember the components of this structure. Oh, but I have it here. So we're going to use the car name, for example. And we are going to just type anything here. This is the car name. So we are telling here the system that the component we want to assign to a component car name this value of this structure, the structure spfli_t. Let's write this to the screen to make sure everything is okay. So we use write variable 1, comma. I don't need to type again write because I'm using a combined syntax. I'm using the comma to write 3 variables at one time, and I use 2 points after write to tell the system I'm doing that. And I'm going to write the last one, the car name. Now remember, we always have to save and activate our program, so we activate, and let's run our program. As you can see, the system prints out 123 Tegucigalpa car name. Domain. The domain describes the technical attributes such as data type and length of a table field. Data element gives the field labels and documentation for the table field. Let's take a look inside the system on how to create a domain and why it is useful for us. Okay, so let's navigate to transaction SEAted, the object navigator. Inside our package of the Abap course, we're going to create a domain. We can do that by right-clicking, create, and choosing dictionary object domain. We're not going to do it like this time because we need to create a data element first and then assign our domain to our data element. So we're going to do it another way. So let's go back to the SAP Easy Access menu. And this time let's navigate to the Abap dictionary. Inside the Abap dictionary, we're going to create a new data element. So we select data type and we type z my underscore data element and we click on create. We select data element, okay. A short description, this is going to be my data element. And the field label, this is important if you want to use your data element to show text on screens. So whenever the SAP system uses this data element, it's going to display on the screen this field label, my data element. Whenever the length of the field is 20 characters or more, it's gonna display my data E. When the field is 30 or more, it's gonna display the whole word. The same for the heading. Okay, so now the domain. First we need to create our domain. So this is gonna be z my domain. And then we double click. The system asks if we want to save first our data element. Yes, we want to save it. We want to save it in our package Abap course. And we have to use always a change request to store our object. So we use the Abap training course. Now the system asks if you want to create the domain. So yes, we create it. And this is going to be my domain description. I want it to be a data type. I browse for the options. I want it to be a character. And I want it to allow 20 characters. I'm gonna save it inside my package. inside my change request, and I need to activate my domain. Remember, we always have to activate our objects. So I use the activate icon, I click, I select my domain. As you can see in our work list, we also have a data element, but we are just working with that domain right now. So we select my domain and we activate. Our domain now is activated. Now let's take a look at how useful domains can be in Abap programs. Let's go back to the Object Navigator. Inside the Object Navigator, let's navigate to our package, the C Abap course, and let's create a new program. So we right click and we create. This is gonna be a Z domain program. We uncheck this. Okay. The program title is C domain program, and it's an executable program, and we save. We save it in our Abap course package and the same request. Now let's take a look at how useful domains are. So for example, let's declare a parameter. So parameters p mat. This is the name of my parameter. I like to use the letter p to indicate that this is a variable parameter. I use the type, and let's use the mat and R data element. This is a standard data element that SAP uses. So now I activate my program. I select it from my work list. Now it's active, and now I run my program to see the result. As you can see, an input field is displayed. This input field was created by the keyword parameters. This means that an input field is created for the user to input a value as a parameter that can be used later on the program. But as you can see, the text here is p_mat. It's the same name as the variable. If we want to change that and use a more clear text, we can use the domain of the Abap dictionary. So how do we do that? We go back, we go to the text elements, and we go to text symbols. We go to the list, to the selection text, and here we can see our parameter listed, and we can type any text we want, or we can use a dictionary reference title. So let's click on this option, let's save, and the system brings the text that is stored in the Abap dictionary for the data element mat and R. In this case is material. So we activate one more time, we go back, and we run our program. Now the program displays the text that it was in our domain, in the domain